Building software has always been a complex task. Traditionally, applications were built as one big unit. This is often called a monolithic architecture. Think of it like a giant machine where all the parts are interconnected. While this approach works, it can become cumbersome as the application grows larger and more complex. This is where microservices come in. Microservices offer a new way of building applications. Instead of one large unit, the application is broken down into smaller independent services. Each of these services focuses on a specific function. For example, an e-commerce application might have separate services for user accounts, product catalog, shopping cart, and payment processing. These microservices communicate with each other to provide the overall functionality of the application. This approach offers several advantages over the traditional monolithic architecture. It allows for greater flexibility, scalability, and resilience in building and maintaining applications. One of the major benefits of using microservices is the increased flexibility it provides. Since each service is independent, developers can use different technologies and programming languages for different services. This means they can choose the best tool for the job without being constrained by the limitations of a single technology stack. Microservices also make applications easier to scale. If one part of the application experiences a surge in traffic, only that specific service needs to be scaled up. This can be done independently of the rest of the application, which improves resource utilization and reduces costs. Another benefit of microservices is increased resilience. If one service fails, it doesn't necessarily bring down the entire application. Other services can continue to function, providing a more robust and reliable system. While microservices offer many benefits, they also introduce new challenges. One of the biggest challenges is managing the communication between these independent services. Since each service is a separate entity, they need a way to discover and communicate with each other. Imagine you have hundreds of these small services running. How does one service find another service it needs to talk to? This is where service discovery comes in. Service discovery is a crucial component of a microservice architecture that helps services locate and communicate with each other. Without service discovery, managing and scaling a microservice-based application would quickly become an unmanageable nightmare. Service discovery acts like a directory within your microservice architecture. It helps services find each other without needing to know their exact location. Think of it like a phone book for your services. When a service starts up, it registers itself with the service discovery system. This registration typically includes information about the service, such as its name, address, and the port it's listening on. When another service needs to communicate with a specific service, it queries the service discovery system. The system then provides the location of the requested service, allowing the two services to communicate directly. Section 5. What is service discovery? Service discovery is a key component of a microservice architecture that enables services to find and communicate with each other dynamically. In essence, it acts as a directory or registry of services within the system. Imagine you have a service called Order Service that needs to communicate with the payment service to process a payment. In a traditional monolithic application, the location of the payment service would be statically defined. However, in a microservice environment, services are dynamic. They can be created, destroyed, and moved around. Service discovery solves this problem by providing a mechanism for services to register themselves and discover other services at runtime. When a service registers, it provides information about itself, such as its name, IP address, port, and any other relevant metadata. Section 6. Client-side discovery, asking around. There are two primary approaches to service discovery: client-side discovery and server-side discovery. Let's take a closer look at each of these approaches. Client-side discovery puts the responsibility of locating services on the client or the service initiating the communication. When a client needs to communicate with a service, it queries a service registry, which acts as a central repository of service information. Think of it like asking your friends for directions instead of looking it up on a map. The client asks around to find the service it needs. The client receives a list of available service instances and their locations from the registry. It then uses a load balancing algorithm to select one of the instances and makes a direct connection to it. Section 7. Server-side discovery, a central directory. In contrast to client-side discovery, server-side discovery delegates the responsibility of locating services to a central component, often a load balancer or a router. This central component acts as an intermediary between clients and services. Think of it like calling a central operator who connects you to the right person. The client doesn't need to know the exact location of the service. When a client needs to communicate with a service, it sends the request to the load balancer. The load balancer then queries the service registry to determine the location of the service and forwards the request to the appropriate instance. Section 8. Popular tools for service discovery. There are several popular tools available that facilitate service discovery in a microservice architecture. These tools provide the necessary infrastructure and mechanisms for service registration, discovery, and health checks. Some of the most widely used service discovery tools include Consul, a distributed, highly available, and data center-aware service discovery tool that also provides features like key value storage, health checks, and service segmentation. Eureka. Developed by Netflix, Eureka is a resilient, client-side service discovery solution that is specifically designed for the cloud and supports features like dynamic registration, health checks, and failover. Kubernetes, an open-source container orchestration platform that includes built-in service discovery mechanisms. Kubernetes uses a concept called services to abstract away the location of pods, which are the smallest deployable units in Kubernetes, and provides a stable endpoint for accessing them. These tools simplify the implementation and management of service discovery in a microservice environment, enabling developers to focus on building and deploying their services. Section 9. Consul, a versatile option. Let's take a closer look at Consul as an example of a popular service discovery tool and how it can be used to implement service discovery in a microservice architecture. Consul is a distributed, highly available, and data center-aware service discovery solution. It provides a key value store for storing configuration data and a DNS interface for service discovery. In a typical Consul setup, services register themselves with the Consul agent running on their host machine. The agent then periodically sends heartbeats to the Consul server to indicate that the service is still alive. When a client needs to communicate with a particular service, it can query the Consul agent for the service's location. The agent responds with the IP address and port of a healthy instance of the service. Consul also provides a feature called health checks that allows it to monitor the health of registered services. If a service fails a health check, Consul automatically removes it from the service registry, ensuring that clients are not directed to unhealthy instances. Section 10. Best practices for smooth sailing. Implementing service discovery effectively is crucial for the success of a microservice architecture. Here are some best practices to consider. Choose the right tool. Select a service discovery tool that aligns with your specific requirements and technology stack. Consider factors such as scalability, availability, features, and ease of integration. Ensure high availability. The service discovery mechanism should be highly available to avoid single points of failure. Use appropriate redundancy and failover mechanisms. Implement health checks. Implement robust health checks for all registered services to ensure that clients are directed to healthy instances. Use meaningful service names. Use clear and descriptive names for your services to make it easier for other developers to understand and discover them. Monitor and manage. Continuously monitor the health and performance of your service discovery infrastructure. Use appropriate monitoring and alerting tools to identify and resolve issues proactively. By following these best practices, you can ensure that your service discovery mechanism is reliable, scalable, and easy to manage, enabling seamless communication between your microservices.
Please like and subscribe to my YouTube channel, and press the bell icon to get the latest updates on technology.